Hi, welcome back to Science 1206, the motion unit. I'm Ms. Ledwell, and in this video, we'll talk about understanding acceleration through graphs. Let's begin. The slope of a line on a velocity time graph is used to determine the acceleration of an object. Just like we did when we calculated slope before with position time graphs, we're going to draw a line from the x-axis to connect to our line on our graph. This line will make a triangle, and now we can find the slope by finding the rise over the run. I remember it as rise up, run across. So the amount we rose up was 8 meters per second east, and the amount we ran across was 4 seconds. 8 meters per second east divided by 4 seconds gives us 2 meters per second squared east. That is the acceleration. The acceleration is 2 meters per second squared east. Let's look at another example. So we're going to find the acceleration from our velocity time graph. That means we need to find the slope. In this case, a triangle has already been formed, and we know the slope is rise over run. How much it rises up is 0 meters per second minus 12 meters per second east, which is negative 12 meters per second east. How much it runs across is t2 minus t1, so we have 2 minus 0 seconds gives us 2 seconds. Then when we divide those numbers, negative 12 divided by 2 gives us negative 6 meters per second squared. It's negative 6, so we can change our direction then to be the opposite of east, which is west. So the acceleration then is 6 meters per second squared west. Now let's look at how to interpret acceleration from a position time graph. The position time graph for accelerated motion, non-uniform motion, is a curve reflecting the change in velocity over time. A straight line with a constant slope on a position time graph indicates constant velocity or uniform motion, and therefore no acceleration. So position time graph 1 with a curved line indicates acceleration is occurring, but position time graph 2 with a straight slope line indicates no acceleration. Some important points to remember are: acceleration is about changes in speed and direction. If neither speed nor direction changes, then the acceleration is 0. Constant velocity represented by a straight line on a velocity time graph equals 0 acceleration. Even if you're moving fast, if your speed and/or direction don't change, you're not accelerating. Now it's time for you to try some practice problems. Pause this video and grab a pencil and some paper, or open up a blank document on your electronic device. As the next slides are revealed, try the problems on your own. We will then review the answer together. After collecting your writing supplies, please resume this instructional video. Our first problem is, which line on the position time graph shows an object undergoing acceleration? And the answer is it's the purple line. A curved line on a position time graph indicates acceleration, while a straight sloped line on a position time graph indicates constant velocity or uniform motion, and no acceleration is occurring. Our next problem asks, find the slope of the line on the velocity time graph to determine the acceleration. The first thing I'm going to do is draw a line to my x-axis to form a triangle. Then I'm going to calculate the slope, and the slope is rise over run. So we look at how much it rises up divided by runs across. It rises up 12 meters per second east, or you could do 12 minus 0 to get 12, and it runs across 2.5 seconds. When we divide these, we get 4.8 meters per second squared east. The acceleration then is 4.8 meters per second squared east. Now it's time to review. Complete the learning activities in Brightspace.